Alright, so this is assignment 1, question 2. I'm going to just load it up right now and show it. This is with it filled in. And there's my circle. And right now I have the number set to 12. So really quick, if I set it to 6, we'll go and see that it has 6 sides now. 6 sides and 6 vertices. So I'll turn this back to 12. We'll go over here. I'll turn this into the wireframe. Alright. So going down here, this took me forever to figure out because of the smallest thing. So I have my vertices array for numbered, so it's the 12. Number of triangles, the number it's -2 because how many vertices you have when we're making this circle, -2 is the amount of actual shapes we're going to have that are triangles. Then I have the indices amount, that'll be later, just so then I had a variable that was one thing. Angle I have set to 0. This will be the thing that will continually be changing and multiplying everything in the for loop. X angle, I have it by pi, which is a float, divided by numbereds, and this whole time I was dividing it by number of triangles. But then as I was looking at this, and I was like, by the number of triangles, why would you do an angle divided by the number of triangles? You're going by each vert and not by the actual triangle itself. And then I realized I was dumb. So I kept on getting 2 shapes less, or 2 triangles less than what I wanted. So, but it still made like a perfect circle. It was just wrong. So yeah, it was number of verts, not number of triangles. And I literally stared at the screen for like 3.5 hours trying to figure that out. For my radius, I have 0.6 right now, just because it kind of looked closer to what yours looked like. Inside my for loop, the x angle, I've multiplied by I, so how many times it's going through. Times by 2 gets angled, then I'm multiplying it using the vertices set function by the cosine for the x times the radius, and then sine of the angle times the radius, and then z, we're not touching z, so I'm leaving it at 0. And then, just like the last assignment, you're multiplying by the number of verts you have, which we already have set up. So then we can continue going down. And then for number of indices, we have this. I have this all just commented out because this doesn't really matter, because once we go down here, we have vertex 2 and vertex 3. So this is every second vertex we look at and every third one. So when we go through here, it starts at 0. It goes to the index amount, which was the 30, which was up here. Which was right here. So it's a number of triangles times 3. So then I only have to do the math once. And so you do that until it passes it. And we do I plus 3 because I'm doing it for every 3. So it's looking at 0, 1, and 2 first. And then it'll look at the next set. So 0, well, not 0, 1, and 2, but it's all these are set to 0 right now. So it looks at the first 3, then the next 3, then the next 3. So basically then it goes, the first one's always going to equal 0 because this is the starting point. And then we go forward 1, and then it equals vertex 2, which is 1 right now. And then it goes in I plus 2, which will be this one, vertex 3, which equals 2. Then we add 1 to each, to vertex 2 and 3. So then this becomes 2 and this becomes 3. So as we're looping through, these continually count up into what they're supposed to be. It doesn't matter how many verts you put in. Now the thing is this probably wouldn't work with 8, just because it's going by 3s and triangles are 3s. So if we're doing not triangles, this wouldn't work unless it was an even number. And then as we go down here, so then this works fine. If we go here, the number of triangles times 3, because this is exactly how it is here, because this was for 1 triangle, so now we need the number of triangles there. And for draw, we have the number of verts minus 2, which is the number of triangles, because this is in another function, so it doesn't have that variable, but I just threw that in. And there we go. So now Just to show it off once again, if we change this to 9, and we play it again, we'll have 1, 2, 3, 4, 5, 6, 7 triangles, but we'll have 1, 2, 3, 4, 5, 6, 7, 8, 9 vertices.